Revised Letters 6, Spacetime Lattice Dimensional Collapse and Topological Membrane Phase Transition. Abstract. This letter fundamentally resolves the mathematical anomaly where a 3D unit lattice volume collapses to zero, 1 times 1 times 0 equals 0, under extreme axis compression. We introduce the topological dimensional collapse tensor, T-collapse, proving that the lattice does not annihilate. Rather, it undergoes a phase transition into a 2D topological membrane, 1 times 1 equals 1, preserving its structural potential energy as an atemporal phase. 1. Formulations of dimensional collapse. The shift of coordinates from a 3D volume element to a 2D topological membrane within the FOXO 16-channel manifold is rigorously defined by the dimensional collapse operator. The integral over the Mobius 16D of the tensor product of vector function w of the partial derivative of r to the n with respect to v, and vector function h of the partial derivative of I to the n with respect to v, taken under the collapse operation, is multiplied by exponential negative I times phi of t times the square root of the negative determinant of g mu nu d sub t, d volume. Subject to axis approaching 0, R3 transforms under the collapse operation to I2, which then implies S of consummation equals epsilon of variable of t, which equals 0 of dynamic. 2. Physical reflux dynamics. When the spacetime density reaches its absolute poles, d sub t equals 1 or d sub t equals 0, the corresponding coordinate axes are compressed into a non-spatial thickness. Instead of a geometric collapse to an absolute zero volume, the spatial scale parameters are mathematically swapped into a hidden imaginary domain, I2. The missing 3D volume energy is not lost, but completely encoded into the curvature tension of the resulting 2D topological membrane. Spacetime acts as a self-conserving, shape-shifting medium across all dimensional cascading levels.